Hello and welcome back to our flight planning course. Section 3, RPAS information. We have a few pages to get through here. Let me just make so that my screen will work with me. Okay, RPAS general information, what to know for flight planning. This is just a list to summarize what we're going to talk about. Firstly, how the system works. How does the remote control connect to a drone? Why are there no cables? 2 is talking about your drone limitations. What can your drone do? What can't it do? How high can it fly? What speeds can it go? 3, battery safety. Batteries are overlooked and are very important. 4, we're going to look at your drone preparation. How do you actually prepare a drone once you know about its limitations? 5, what info to look for. So where do you find out what you need to for your drones? And how do you get that information? Specifically, what information are you looking for? 6 is where to find the info. 7 is control of the drone. And 8 is talking about radio signals and data links. Now, we'll talk about that a little bit when we get to that page coming up.
Hello peeps, excuse my informal attire. I was at the gym and I'm too lazy to get changed into it's frickin' hot. So I'm not going to be getting into my work clothes today. That's not important. What is important is that this is another Josh from the future moment, another video that I'm throwing in amongst this video. It seems this section 3 video is the one to do that because I left a little bit of stuff out. So the main thing I want to discuss right now is that this section is going to discuss a whole bunch of things. It's going to teach, I'm parting with a lot of information in this video, but I realized that I didn't actually explain the reason behind all of this information. I just gave the information. So this video is going to settle that. Okay, this video is going to discuss the importance of the information to come in this section, in section 3. So the main thing that I want to discuss is that you need to first and foremost you need to ask yourself a few questions before you start. In order to decide on the type of drone you want, the type of mission you're going to do, you need to ask yourself a few questions, all right? Because this section is all about finding the right RPAS. It's all about setting up your RPAS, deciding on a drone, looking at things like that. And within the next couple sections, we look at drone limitations. We look at limitations of an RPAS setup. You know, some drones can only go so far, some drones can only go so fast, things like that. But why do we need to know about that stuff? I've got a format that we can use to identify all the questions that we might want to ask ourselves in order to identify what is the best type of drone and or RPAS to use for what we want to accomplish. It is the 5 W's and an H. The 5 W's are literally who, what, when, where, why, and the H is how. If we go into them, if we start with who, you can think who will be flying. What, you can then think what will you be flying, when will you be flying, where will you be flying, why will you be flying, and how will you be flying. Not necessarily in that order. You might want to rearrange the order depending on figuring that out first. For example, I would not say what am I flying as second, because I would first want to know who, when, where, and why. For example, if I don't know why I'm flying, which is the first one I would actually answer, how am I supposed to know what am I flying? I bring this example up a lot. I don't know where I fit it in, but the example of anti-poaching, covering a game farm for anti-poaching. If I said what will I be flying, a multi-rotor, and then I said why will I be flying, anti-poaching, great. Okay, now I have to go back through all the questions that I've already answered and re-answer them because my why doesn't work out. But that is a reason why these questions are all here, because sometimes you do answer a question that you're set on or you're sure of, and then a question that comes up later, you identify that your previous answer for a previous question doesn't actually work out. If I answered who first, then I'd say who is flying? This person. Then later on I said when am I flying, and it says nighttime. What if that person that I had decided is flying can't see well at night? Then I have to change that. So that's the purpose of all of these questions here, is they allow us to make sure that we're going to plan the mission with the exact right system, the exact right equipment that we need to make sure that it works out properly. I'm not going to go through them all now. This video will be way too long. if I were to go through every single example. We're going to be putting these in an example in the second course when it comes out. All right, the case study course. So if you are interested in that, obviously continue doing this course. You're in it now, you're deep in it now, but go to the second course if you want to actually know how to do these things. Also, I haven't mentioned this yet, but there's a bonus. I don't think I've mentioned this yet. The bonus is that the second course comes with a ready-made professional field operations manual with all of the stuff included. The first section is literally these questions. What I'm going to do is I'm going to, as though I am going to be flying my own mission, I'm going to fill in an FOM according to that. So I'm going to answer these questions for myself. I'm then going to do all the other things, all the pre-flight checks, all that stuff that's coming up that you're going to learn about in this course. Here are the abbreviations summing up. So RPA is your remotely piloted aircraft or the drone itself. RPS is a remote pilot station or the remote control in a basic setting. And RPAS is your remote pilot aircraft system. It's the RPA and RPS together. It is a remotely operated system, which means it works without cables. You do something over here and something happens over there without it looking like there's actually any real connection between the two. It is an unmanned flying machine and it uses radio signals to connect to each other. So that's how the whole system works together. It might look like it's not really connected, but it is connected. It's connected via radio signals, radio wave frequencies. The way I describe this, there's something called a C2 link. The C2 link stands for the command and control link. The C2 link is the invisible cable from my remote control to my drone. Literally, you can think as though there's a wire, and it works the same way as a wire. A wire only has a certain length that it can extend to before there's no more wire. A C2 link is the same thing. A C2 link only has a certain limit that it can go before it's going to cut out, and the radio waves are not going to reach further than that point. You have flight rules and line of sight. This is important because of the way you fly a drone has to be in accordance with what you can fly, what you are rated to fly, and what your governing body says you can fly. When it comes to flight rules, we are talking about things like how high are you allowed to fly? How far away are you allowed to fly? In what airspaces are you allowed to fly? In line of sight, we are talking about, is it a VLOS, which stands for visual line of sight? Can you see the drone? Is it BVLOS, which is beyond visual line of sight? Are you behind an object or are you too far away to be able to see the drone? Potential risks and issues with the setup. You need to look at what do you think can go wrong with your setup. You can refer to the drone's manual for that. You can also look online for some information there. And then finally, you have fail-safe and emergency procedures. You need to know what sort of fail-safes your drone has. You need to know how to use them. And you need to know what the procedures are in any sort of emergency situation involving your drone. Okay, so I'm adding this little section in here a little bit later on. Actually a few days after I recorded this, because I realized that in the recording I didn't actually explain what a failsafe is. To understand a failsafe a little bit better, let's first understand the difference between a malfunction and an emergency situation. A lot of people see the two and think, well, aren't they the same thing? No, a malfunction can lead to an emergency unless we have the appropriate failsafe in place to prevent the emergency from occurring. So a malfunction is when one of our primary systems fails. We then need something to back it up to prevent that failure of a component or a system from turning into an emergency. So if we take an example, I'm going to use the most extreme example because it's the easiest one to understand. All right, it's literally the final failsafe that you could ever have on any system, and that is a parachute system. In this parachute system, what will happen is if we are flying our drone, and our drone has an engine failure, the drone's brain or its computer chip, its computer memory will identify that the motors have cut out and that the drone is now falling to the ground. In this case, it will then automatically release a parachute, and you will have gone from an emergency situation to just a very tedious situation. You have prevented an emergency from occurring because of your failsafe, right? The emergency would have been if the drone was falling to the ground. You're going to lose your drone. It's going to damage whatever it hits. It could even kill somebody. But if you have it floats to the ground using its parachute, its final form of a failsafe, nothing terrible is going to happen. You might still lose your drone. It might go into water or something like that, but you're not going to be faced with dire consequences like
lawsuits or even, court cases and stuff like that. An RPAS is only as good as its biggest weakness. A pilot's job is to identify weakness and establish a workaround. So it's your job to identify the limitations of your drone and figure out how you can use the drone that you have. Alternatively, it is up to the pilot to decide to fly based on said weakness. If you know that your C2 link, your radio connection is not a strong connection and you want to fly surrounded by Wi-Fi signals and satellite signals, it's your discretion as the pilot. You can say yes or no, I want to fly based on risk assessment and risk mitigation. Generally, you're probably going to say no, I want to strengthen my C2 link instead. In this case, it is important to assess the potential risks of the weaknesses. So in that instance, you would then say, well, the risks are, what are the risks? If I fly too far away, my drone might disconnect. I might even have a flyaway. And a flyaway is an emergency situation. All right. So how do I prevent that? Well, as the pilot flying in this situation, I can mitigate that risk maybe by making sure I fly close to me. Drone limitations. Knowing what a drone can and can't do is vital. You can't plan a 20-minute mission if a drone flies for only 10 minutes. That's like the most basic example ever. If my drone is only going to last 10 minutes in the air, I can't plan to fly my drone for 20 minutes, can I? No, I can't. Okay, that's a limitation. You can't fly in strong wind gusts if the drone isn't strong, and you can't fly long distance if the radio signal or the C2 link does not reach that distance. So where do you find this information? Where do you find it? You go to your drone manual. Your drone manual is going to have this information in it. If you cannot find it or you don't have the drone manual, you're going to go onto the website. For example, if I'm flying a DJI product, I'll go onto the DJI website. I'll type in the model I have and I'll look for the specs. You also need to look at regulations. There are limitations when it comes to regulations. Unfortunately, that's just the way it is. We will look at regulations, where to find them later on. But you need to look at your drone limitations as well as any limitations that you might face based on the regulations or the law of where you are flying. Battery safety. It is important as batteries are unsafe and overlooked. One of the most dangerous components of the whole RPAS is your battery. Because we're so accustomed to using batteries and not having issues, batteries are often overlooked. If you have a lot of batteries, a lot of LiPo batteries, which is generally what drones use, you need to put them in battery bags. Next, you need to check your battery charge status before leaving. This is crucial. We'll talk about this as we go through our flight planning, but if you are going to go fly a flight and you're going to drive 2 hours away, and this doesn't just include batteries, this includes your whole system, you need to do a system check before you drive to where you're going to fly. If you drive to where you're going to fly and it turns out your battery isn't charged, or it turns out you don't have a propeller, or it turns out your drone isn't able to fly, you spent 4 hours driving where you didn't need to. Of course, you need to check your battery condition. Before every single flight, you are going to check your battery condition. I don't care if it is your most favorite battery that has never had anything bad happen around it ever, and it's always been in good condition. You check it. 80-20 and cycle depletion. Okay, depending on the regulations, you're going to have a certain percentage of battery that you need to have when you land. If you go below that, it is an illegal procedure. For us in South Africa, it is a 10%. However, 10% of a battery is a terrible idea. So we have what is called, and it's understood around the world, you want to use 80% of your battery and you want to have it stop the use at 20% of the battery. So yes, the regulation says 10%, but no, we want to aim to land at 20%. So generally what we do is we set an alarm for 30%. At 30%, an alarm goes off and we know that, okay, we need to start heading for landing now. The reason 80-20 is important, not only because 10% your battery, you don't have enough battery to do a proper landing, you have to do a quick landing, but from 20% onwards, your battery depletes a lot faster. Where normally you would have had 2 minutes per percent, you might only have, or let's say 1 minute per 2%, you might only have half a minute per 2% now from 20% below. And when it comes to cycle depletion, we're talking about a battery, how many times a battery can be recharged and reused. If you keep going below 20% as you use your battery is more likely to have a shorter lifespan, which means that its cycle depletion is going to increase. You're not going to be able to recharge it and reuse it as much as if you had a battery that you looked after and didn't go below that 20%. All right, this is just something I threw in there because it is important and it is something that a lot of people don't think about. You get car charged batteries, not the batteries itself, but the charging cables that you can plug into your car and charge your batteries in the car. Even if you do end up leaving your batteries at home or they're half charged or whatever, as long as you have at least one battery, you can come and do your flight and recharge that battery. It will take a long time. It'll take the whole day to do flights like that, but you could do it. On to drone flight preparation. This is just going to be kind of telling you what we need to do in order to prepare for our flight. So firstly, you need to check everything before leaving for the field. You do a pre-flight check, which we'll talk about now, but a pre-flight check is basically where you check all the components of your drone, as well as your remote control, as well as your propellers, backup propellers, batteries, backup batteries, your drone manual, your documents. You check every single thing. You're even going to check your car. A lot of people don't think to do that. Then they drive somewhere and they get stuck. Maybe they hit a rock along the way. Because usually when you're flying drones, you're not going to be on well-tarred roads. Generally, you're out in the bush and you might hit a rock and then there goes your tire and now you don't have a spare tire. What are you going to do? You're going to be stuck there. You need to check everything. So it even includes not just down to your documents, but things like, do you have water? Do you have food? Do you have sunscreen? Do you have weather protection? Then you need to check your drone performance and limitations. Where do you do this? Go to the next slide. You read manuals. Okay, you read the manual of all the equipment and all the components. Your battery has its own manual. Your remote control has its own manual. Antennas will have their own manual. If you can find a manual for every single thing you have, like, kudos to you. If you buy something and it comes with the manual, keep that manual with you. Have it when you fly. If you don't have that manual, you can find the information you need on websites online. You can even find the manuals online as well if you do some digging. You need to undergo the training or practice before mission. So it doesn't matter if you're licensed or not. If you don't know how to fly, you clearly can't fly for a mission. You need to at least practice or at least learn how to fly a drone first before you can fly a mission. You need to be aware of orientation and control issues. The biggest thing that most students struggle with when it comes to actually flying. When a drone is flying, its orientation changes in the air. But us standing still on the ground, our orientation doesn't change with it. If, let's say I'm flying straight away from me, then I turn my drone to face the right of me and I fly forwards. If I'm flying forwards, the drone's going to go this way. It's not going to keep going forwards. So the drone's heading and orientation has changed, but mine hasn't. I'm not going to do this to match the drone and see that I'm flying it. I have to stay still so that I can pay attention to everything that's around me. And when I'm talking about control issues, I'm talking about things like actually knowing how to control your drone. For example, if you're about to crash into something, simply leaving the remote control is an important thing to know because the GPS lock is going to stop the drone automatically. That's then dealing with things that are called flight modes, GPS lock mode or position mode. Okay, you need to be aware of nearby radio or data link signals. If you are surrounded by satellite signals, your drone is going to struggle to have satellite signals. So GPS signal might be a little weaker. If you're surrounded by radio signals and Wi-Fi signals, then your remote control signal is going to be weaker. You then set up the RPAS according to the drone manual. Before you fly the drone, you need to make sure that you set your drone up. This includes things like trimming. Trimming is basically if you are in GPS lock where your drone is supposed to be sitting still, but you can see you're not pressing anything and the drone is going a little bit to the right. You're going to trim the drone to the left until it stops moving to the right, and then it's trimmed properly, and then it will be stable. The manual will walk you through how to trim the drone. It also includes things like how to calibrate your drone, how to make it so that the drone knows where it is and finds its GPS signal. That is a calibration process. Again, the manual will show you that. Once you've trimmed the drone and you've set it up according to what the manual says for first-time flight or for repeated flights in different locations, you're then going to test fly your drone. You're going to make sure that it works properly, that it's calibrated, and you're going to check if anything feels off or wrong. If I push forward and my drone 1, 2, 3 and then flies forward, I'm not going to fly. I'm going to figure out why there's such a lag. Set up fail-safes and test during the test flight. I said test during the test flight because the way I do it is I do all the trimming and stuff and I set up the fail-safes at the same time. If you're new to the fail-safe situations, I would say first start with the trimming and the calibration. Just get used to that stuff, just the basic setup. Test fly that to make sure that's working properly. Really a low test fly, okay, not far away from you at all. Then come down and land your drone. Then set up your fail-safes. Your manual, once again, is the place to look to set up your fail-safe. It'll tell you what sort of fail-safes the drone has. Most drones nowadays have what is called a return to launch or a return to home, RTL, RTH. It's literally, in some cases, a button on your remote control. You press it and the drone will come. Depending on what you set up, either the drone will land where it is or it'll bring itself back to land where it took off. You need to then set up any other functions such as geofencing. Any other functions is basically if you have a more advanced RPAS and your technology can do more to make the flight more safe, you're going to want to set those up. Geofencing literally makes it so that the drone thinks it's in a room. The drone thinks it's inside a room, and when it hits that wall, no matter how much you push on the remote control, the drone will not fly out of that wall. This is great for things like flyways. If you're having a flyaway where your remote control isn't working and your drone's flying itself, it's going to hit the wall or the ceiling and it's going to stop itself. Okay, it's not going to go further than that. Unless there's something intrinsically wrong with the drone, which in some cases there are. You know, there's still technology and technology does still fail from time to time. And finally, you need to know how to calibrate the drone to position. Now, I should have put that up there with trim drone, but I wanted to end on this point because it is the most important point. You cannot expect to fly a drone in GPS lock or safely where it will hover in one place if you don't calibrate the drone to its location. You cannot expect the drone to return itself to where it took off if it doesn't know where it took off. On the side there, I've just got an arrow. If you're going to be studying these slides by yourself, I'd recommend looking at the arrows more than looking at this information. All of that is important, but this arrow will walk you kind of through the summary, the summarized version of everything in the block. Okay, now we need to know what to look for. What information are we looking for and where are we going to find it? The most of this information can be found in the drone's manual. This is known as the POH or the Pilot Operating Handbook. It's a fancy way of saying manual, really it is, but it is the term that aviation uses. Any info for a particular component can be found in its own manual. This manual will come with the components. If you can't find it, if a manual is lost or not present, you can use the internet. There are multiple ways you can do a pre-flight check, and you need to take your time when you do this. I know it looks easy and simple and it's just the same thing over and over. You're just looking at the drone again, but it's important. Between transits, from here to wherever I've driven, I can have a crack caused in my drone. I can have something fall out. All right, I'm throwing another little makeshift video in here in amongst, well, not really a makeshift video, but another video from the future for the past in amongst the section 3. And I don't even remember why. Oh, that's right. So I realized that in the slide I said pre-flight check example, and I realized that that's not really it's not an efficient thing to do because it's not really going to work. Because if I was going to do a pre-flight check example, it was going to be with the Phantom 4. Now that's a specific type of drone. So you do a pre-flight check different based on the drone you have, right? If you build your own drone, you're going to go internal to it. If you have a fixed wing, it's going to be a completely different type of pre-flight check. Even if I have a different type of DJI quadcopter multi-rotor, it's going to be a different pre-flight check because they all function differently. For example, an Inspire's pre-flight check also has to include the raising and descending of the landing gear. So all these different things that it's not efficient for me to just do a half-hour pre-flight check and throw it in this video when probably most of you aren't going to be using Phantom 4s. So what I've decided instead is that I'm going to save that for course 2. For the second course, I'm going to save a pre-flight check example and demonstration for the second course. What I am going to do now for the example is just run through the things that you should check. You essentially need to check everything of your aircraft that you can check. All right. So if you can check the motors, you're going to check the motors. You're going to do a visual inspection of everything. You're going to make sure that there are screws in where the screws need to be. There are no cracks where cracks shouldn't be. You know, everything inside your battery slots is safe and compounded. You're just going to check everything of your aircraft, and you're going to do it in one foul swoop, one fluid motion. You got to check the top of the aircraft, you got to check the sides of the aircraft, and you got to check underneath the aircraft. You're going to check screws, you're going to check the motors, you're going to check the resistance of the motors, you're going to check your camera, your payload, your gimbal, you're going to check the wobbliness, is it attached, is it steady, is it going to come off, you're going to check your landing gear. You literally are just going to check every single thing that your aircraft has to show you. And that's that. It's actually really that simple. It's going to take a lot longer. I did have an example, a demonstration in here of the Phantom 4. That's why I realized it wasn't an effective way to go. It made this video almost an hour long. So it does, if you do it thoroughly and properly, it does take a long time because you have to check beyond your pre-flight of an aircraft. You have to check your batteries. You have to check your remote control. You have to check your manuals. Are you able to read them? Are you able to understand them? You have to check your documents. Literally, you can understand, right? You can understand why it wouldn't be a good idea for me to try and run through everything that you're supposed to pre-flight check and do a demonstration. The second course is literally a full-blown case study of everything we learn here. Right from the start, questions like, what is the purpose of my drone, or what is the purpose of my mission, what sort of drone should I have for the mission, all the way up to actually filling in a field operations manual, which includes a pre-flight check on specific components of our RPAS. So if you are interested in that, if you want to know how to do it, intrinsically, please go over to the second course, which for whoever is just getting this course at the very beginning of it being released, that course isn't going to be out yet. It's going to take me a little time to release that course. But for anyone who's maybe after a month of this course being out, you'll probably have access to that second course. I might even put it at the end of this course. I'll throw it in there, maybe even with a code, an access code, so that you can get a discount or something like that. All right, cool. There are pre-flight check lists that you could find on the internet. You can find it from schools. I do have a second course that is coming out, and we will do all these things in a detailed example, a case study, basically, where I will have an example of this document. So anything that talks about documents or examples or things like that, and I don't have a document for it, that's why there is a second course that is a case study of everything we learn in this course. That was a bit of a big section there, and we are not done yet. We still need to talk about controlling the drone and data links and radio signals. When it comes to controlling the drone, you need to be able to control the drone in all situations. What that means is if it is heavy wind, you need to be able to control your drone. All of a sudden you have your drone switches into a different flight mode. You need to be able to control your drone. You cannot go on a mission if you aren't aware how to control and manipulate your drone, no matter the circumstances. You need to be aware of orientation and control issues, which we talked about previously. Be aware of situational awareness and VLOS. Situational awareness is talking about your surroundings. Are there other aircrafts in the air? Are there people around you on the ground? Are there buildings nearby? Are there roads nearby? What sort of environment are you flying in? VLOS is your visual line of sight. Can you see the drone or can you not see the drone? You need to undergo drone training and practice. It is very, very rare that someone just picks up a drone remote and just flies a drone perfectly. And you must practice with a specific drone before a mission. Drone schools, all drone schools use different drones, but they tend to use a standardized multi-rotor. If you have to fly a drone that now has 6 rotors, or you have to fly a drone that is completely different, might still be a quadcopter, but it's completely different to what you trained on. Of course, you want to practice flying that drone first before doing your mission. Next little category here is your data links and radio signals. You need to be aware of RPAS R loss, which is a radio line of sight. Radio line of sight is like visual line of sight for your remote control. How far can your remote control see the drone? How far can the radio waves and the radio frequency reach to communicate with the drone? That is radio line of sight. You must also be aware of any other data or radio links. What is a data link? A data link is an invisible connection between 2 points upon which information is sent and received. The C2 link is a data link because the C2 link is an invisible connection from the remote control to the drone that sends and receives data. I say on the remote control, I say go forward. It sends that information to the drone then goes forward. All right, so when it says there, be aware of any other data or radio links, let's talk about external links first. If you had someone else flying a drone near you, it's going to be using the same frequency as your drone, most likely. Maybe they've changed this a little bit, but usually it's going to be on the same frequency that my remote control to my drone is communicating on a 2.4 gigahertz, for example. and their drone is also communicating on a 2.4 gigahertz. Our frequencies can interfere with each other. If we are too close to each other and they are not strong enough, they will interfere with each other. So you need to be aware of that. Now let's talk about an internal separation of data links. If I have a C2 link on 2.4 gigahertz and I have a camera on my drone and a screen on the ground, they also have to connect through a data link, right? I can't have a wire running from my screen on the ground up to my camera in the air. It's going to be an invisible connection. It's going to be another data link. However, I might not want it on the same frequency. I don't want that on 2.4 gigahertz. Why? Because if I have two data links on 2.4 gigahertz and they're right next to each other doing this, then of course they're going to interfere with each other. So generally you're going to have your camera on 5 gigahertz, but it depends how you set it up. You can set it up 2.4 gigahertz. You can do all these fun workarounds. There's a lot of interesting stuff you can do with the technology nowadays. You need to also be aware of nearby links such as satellites, Wi-Fi, or drones. So that covers the previous example. Be aware of landscape and obstacles. The reason this is important for data links is because a radio frequency does not actually go through things. It does to an extent, but it does that by going through on a molecular level. But usually if it can find an easier way, it's just going to go around things. If I have a drone right there and I shoot straight forward, it's going to hit the drone. But now if I face this way and I shoot my signal off that way, it's going to go that way, hit something there, bounce off of it, and then make its way here. You can think of it as like a target missile that heads where it needs to go, but it'll sometimes do that by heading somewhere first and bouncing off of that. So that's talking about your obstacles. You need to be aware of obstacles. Are there things in the way? If I have a perfectly open field and my remote control will reach the drone across this whole field, except behind in one place, and that is just behind a tree on the field, then of course I know that there's an issue because the radio signal is not strong enough to get through or past that tree. Landscape is important because of mountains, right? If I'm flying over and beneath a mountain, my radio signal has to go over the mountain, which means it has to extend itself, which means I need a strong radio signal. Otherwise, generally, it's going to try and cut through the mountain and come dead end or halfway. It's not going to get through the mountain. Also, water. If you have a body of water, if you're flying next to a body of water, the radio signal gets absorbed by water, so it doesn't bounce off water. If you could normally fly 8 kilometers on land, you might only fly 4 or 5 kilometers on water before your drone disconnects from the remote control. When you fly, it is crucial to turn your remote on before you're turning your drone on. The reason being is because if I turn my drone on first, and then I go and turn my remote control on, my drone can have already connected to something else, and it can fly away. All right, that was section 3, RPAS setup and RPAS information. We then are, in the next section, we are going to be talking about RPAS setup in action. We're going to take everything we learned here, and we're going to just go through a quick step-by-step process on how we actually do or use the information that we've learned through this section.